Okay, so Jan 22, paper 2, higher regional. Let's do this. Okay, we've got the formula sheet as per usual. Yeah? So here we go. Let's do question 1. Question 1 is probability. A tin contains tea bags with a choice. Oh my God. What does this mean? Oh, hello. Right. Wait, what am I saying? A tin contains tea bags with a choice of 4 different flavours of tea. I can't believe it. The 4 flavours of tea are Assam or Darjeeling or Nilgiri or rice. Okay, guys, this is what's going to take most time is trying to read the questions. Sarah takes a random tea bag from the tin. Blah, 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 blah. What do we know about probabilities? They add up to 1. So if I do 1 minus 0.38 minus 0.24 minus 0.16. Sorry, all of these added together, isn't it? And then I'm going to get 0.22. Perfect. Work out the probability that the flavour of C Sarah takes is either Darjeeling or rice. Darjeeling or rice. Yeah, we're going to add them together. I can't believe how simple this is. Okay, what do we get? 0.4. Okay, absolutely perfect. Well done, guys. 2 marks for adding. I can't believe it. Right, question 2. How many marks is this? Okay, Mary saves for a holiday each year. In 2020, she saved $720. In 2021, each month, she saved $78. Okay, will someone tell me how many months in a year? Oh, tell you what, clever little bunnies. 936, right? 936. It says the total amount Mary saved was P% more. Now we know using the multiplier method, 720 times something is 9,360. Okay, so we're going to divide 936 divided by 720, right? I get 1.3. Okay, 1.3. What is that as a percentage? That means that's an increase of 130%, but it means it's 30% more. The final answer is 30% more. Now, if you wanted to do this a different way, we could have done it another way. Another way we could do this, we could think about it, if we're not using the multiplier way, like this. 720 to 936, what's the difference? 936 minus 720. So we added 216. What's 216 as a percentage of 720? 216 divided by 720 is going to give me 0.3, which is 30%. Okay, either way is completely correct. Depends how your brain works. Question 5. Oh my God, there's a part B to it. Jeez. Roberto is going on a holiday. He's got 2 coupons that will save him money on his holiday. For Roberto's holiday, the cost of accommodation is $1,600. Cost of the flight is $800. Roberto can only use one of the coupons. He wants to save as much as he can. Okay, so let's figure it out, right? Coupon A. Now I'm going to do this here. This is A. Coupon A. 18% of the cost of accommodation. Okay, brilliant. So we know we've got 800 because the flights don't change, right? Plus 1,600. How am I going to find 18% off? Is 0.82. Okay, this is already going to have that reduction, isn't it? Or you could find 18% and subtract it off. There's loads of different ways. I really love the multiplier method. So 1,600 times 0.82 is 1,312 plus 800. So for coupon A, he's going to spend a total of $2,112. Okay. Now, coupon B says 12.5% off the total cost of accommodation and flights. So accommodation plus flights is 2,400. 2,400 times, what's 12% off? So if I want 100% minus 12.5% is 87.5%. That means that's how much I want of the number. As a multiplier, 0.875. So 2,400 times 0.875 is going to give me 2,100. Okay, I'm not going to leave it there because it says which coupon should he use? B, absolutely. Coupon B, because he saves $12 more than coupon A. Absolutely. Perfect. Okay, next up, here we go. Question number 3. So 4y plus 5 is greater than 12. Now we know we're just going to treat this as a bit of an equal sign. 4y, if I take away 5 from both sides, is greater than 7. Now I'm going to divide both sides by 4. Y is greater than 7 over 4. Now if you wanted to, you could still write that as y is greater than 1.75. Either way. Either way. Okay, part B. 6x minus 5 equals 4x minus 7 over 2. First thing I'm going to do, multiply both sides by 2. So I'm going to get 2 lots of 6x minus 5 equals 4x minus 7. I'm going to expand the brackets. 12x minus 10. Okay, do you have to do it the same way as me? Absolutely not. As long as we get the same answer, it's okay. It's mathematical manipulation. I'm going to take away 4x from both sides. 8x minus 10 equals negative 7. What am I now going to do? Add 10 to both sides. 8x equals 3. Divide by 8. X equals 3 over 8. Now, how can I see if I was right? Leave it as a fraction. No, well, did you put 0.375? Now, we can actually check if this is right. This is crazy. Are you ready for this? We're saying 6x minus 5. So we're saying 6 lots of 3 over 8 minus 5. We're saying that is the same as 4 lots of 3 over 8 minus 7 all over 2. There's no need for you to ever get this wrong. So let's try it, shall we? What is 6 lots of that minus 5? I get minus 11 over 4. Everyone happy? Yeah, if I type it into the other side. Guys, what do I get? Minus 11 over 4. You always can know if you're right. Yeah? Go. Huh? Texas. I don't know which type, but these ones are okay. Question number 4. Diagram shows a rectangular octagon and a rectangular pentagon. Work out the size of the angle X. Okay, so first of all, pentagon. Now, if you've forgotten the formulas, it's okay. There's like a bit of a trick, isn't there? For a pentagon, it's 5-sided. Now, the formula of the interior angles is n minus 2 times 180. However, if you've got it, it's okay. Because do you know how many degrees are in a triangle? 180. In a pentagon, I can draw 3 triangles. So that's 3 times 180. Okay? Oh my. So, 3 times 180 is 540. 540 divided by 5? 108. Okay? So that means each of these angles is 108. Beautiful. Now we have a, what's this? Octagon. So then the octagon is 8 minus 2 times 180. So 6 times 180, because octagons have 8 sides, right? 1080. And then if I divide that by 8, 135 degrees. So then I know that the whole of this is 135 degrees. I'm going to minus 108, and that's going to give me this little angle, isn't it? And what is it? 27 degrees. Okay, this is great. Now what do I do? I did the octagon. All of these angles are that. Is BCI 90 degrees? Definitely not. Okay, let's have a look at this right now. Okay, it doesn't technically say anything about anything apart from what we already know. What else do we know? Let's figure out what we know. We know that this is 108, okay? Okay, so we know that this is 108. Oh my God, you're never going to believe it. 108. What do we know this is? Also 27. Okay, let's have a look at what this shape is. This is crazy. 1, 2, 3, 4, 5, 6. Forget about, oh yeah, we could do this. 7, 8, 9, 10. It's a 10-sided shape, this blue shape. How many angles in a 10-sided shape? Yeah, 10 minus 2 times 180. What do we get? 1440. Okay, this is what all the angles need to add up to. Now, what do we know? We know. What is this angle? 135. Okay, 135 times 1, 2, 3, 4, 5. Everyone happy? Yeah? What is 135 times 5? 675. Is 675. Okay. We know that this is 27. So we're going to add 27. Okay. What is this angle here? Yeah, 360 minus, which is? 252. So we have 2 of those. 2 times 252. What do we get? 504. Because we did 135 minus 28. Oh, I just realised I don't know this angle either. Okay, so now we've got this angle left and this angle. And that's the issue. Okay, so here we are getting all technical. This is what sometimes I hate about these types of questions. Are you ready for this? We are silly. So silly. You're just never going to believe this. Right, let's get rid of everything that we said was happening. Oh, it won't let me... I don't understand what happened. It just won't let me think away now. You never guess what. Right? Working out that 27 was probably the hardest. You see this triangle? It's isosceles. Because the regular pentagon and the regular hexagon clearly have the same size. So this is actually, silly sausages, 180 minus 27 divided by 2. Yeah. Which is going to give me 76.5. It's because this triangle is isosceles. I tell you what, we are silly billies. And do you know what? If that happens in your exam, that is okay. Because we realised there was something wrong when we had another 2 unknowns, didn't we? Great work. Question 5. Shane invests $7,200 for 3 years in a savings account. He gets 2.5% per year compound interest. How much money will he have in a savings account? Oh, what a lovely question. 7,200. 2.5%.
0.025 times to the power of 3.
To the power of 3. Absolutely. Okay, so increase to 2.5%. 7,200 times 1.025 cubed is going to give me 7,753.612, etc. to the nearest dollar.
7,754.
7,754. Woohoo! Okay, question 6.
1.
X to the power of 0. We all know it's
1.
brilliant. Given that 2 to the power of minus 3 times 2 to the 9 equals 2 to the n, what do we do when we multiply powers? Add them, so this becomes 6. So n equals 6. Brilliant. Okay, what happens here? So we add the top. Now, guys, there's 2 different ways we could do this. So let's just do what you're saying. So it's going to be 206 plus m. Okay, and then divided by 7 to the power of 214. This means 206 plus m minus 214. What does that equal? Yeah, 7 to the minus 3. So this equals 206 plus m minus 214 equals minus 3. Yeah, we can add 214 to both sides. What do we get? 211. Take away 206. 211 minus 206 is 5. So m is 5. Wasn't that beautiful? Lovely jubbly. All right then. Question 7. Write down the equation of the straight line with the gradient minus 3. So straight away we know y equals mx plus c, right? So we know y equals minus 3x. And it passes through the point 0, 5. Well, that's fantastic, because that means the y-intercept. So it's just plus 5. Now, let's say it said it passes through the points 1, 5, right? I would just substitute in 5 into where y is, equals minus 3 lots of 1 plus c. Yeah? Okay, we all know how to do that. Perfect. Oh, lovely. By shading. Now, step 1. When we shade this, we're going to shade straight lines. Yeah? So, x is less than or equal to 6. We're going to draw the line x equals 6. Where does x equal 6? Always. Always equals 6 on here. Okay, this is the line x equals 6. Because any coordinate on this line, x will equal 6. Yeah? Okay. If we want less than that, it's going to be less than 6. This is the part that we want, isn't it? Yeah? So I've shaded that all in. Lovely. Y is greater than 2. Where is y always greater than 2? Where is y always equal to 2? Here. Any point on this line, y equals to 2. If I want greater than 2, it's all up here, right? Brilliant. Next one. Where is y equals x plus 1? So it crosses at 1, and what's my gradient? 1. So for every 1 across, I go up. Every 1 across, I go up 1. Okay? If you don't want to do that, you can just do this, right? You can decide, okay, I want to know what happens when x is 0. Y equals x plus 1. When x is 0, what does y equal? 1. And then you can look for the biggest number here. What's this? 10, yeah? So you can say, right, when x is 10, what does y equal? 11. Okay, it doesn't help us because it goes above. So then I think, right, choose another random number. When x is 5, what does y equal? 6. So I can literally go across 5 up to 6. You only need 2 points to draw a straight line. Okay, so now we're going to draw this. Using a ruler and a pencil, absolutely. So there's that line. It says it wants less than. If we want less than, it means we want below the line. Okay, where were they all highlighted? Yeah, in this middle triangle, so we're going to label it R. Perfect.
Can you highlight this in the exam?
Yeah, you can highlight it in the exam, you can shade, anything. Okay, question number 8. A scientist is investigating the weight of 50 tigers. Oh my. Here are some information about these tigers. The mean weight of all 50 tigers is 218. So that, how do I work out the mean? If I add them all up and divide by 50, I get 218, right? But they've also told us that the Siberian tigers, there's 22 of them, and if I add them all up, divide them by 22, what's my mean weight? 260. Okay, so let's find out the total weight of all the tigers. This is the Siberian plus the Bengal. Okay, so 50 times 218. So that means the total weight is 10,900. What's this one? Siberian. So what's the total weight of the Siberian? 22 times 260, which is 5,720. So am I able to work out the total weight of the Bengal?
You minus it.
Yeah, I minus it, absolutely. 5,720, so 10,900. Minus this is going to give me 5,180. So that's the total weight of the Bengal. So 5,180 divided by 28 is going to give me the mean, which is 185. There we go. Nice and easy. It's a combination of mean. Lovely. Question 9. Oh, wow. What's happening here?
It's actually very, very easy.
Okay, in the diagram, ABC is a right angle triangle and DEF is a semicircle. In the triangle, they've given us 24, 90, brilliant. Points D and F lie on AC so that DF is the diameter of the semicircle. The radius of the semicircle is 3. Right, so if the radius is 3, what do we know about this length? Yeah, this is actually 6 because it's 3 plus 3, yeah, which is 6. Work out the length AF E DC. So it actually wants us to work out, it actually wants us to work out this, this, and this. Okay, so first of all, step 1, I'm going to break this up. I'm going to find the length of the hypotenuse using what? SOHCAHTOA. Okay, so hypotenuse, this is the opposite, this is the adjacent. Yeah? Well, let's see, what do we want? H, what do we have? A, what is this? Cos. So, cos of the angle equals 24 over the hypotenuse. So that means the hypotenuse equals 24 over cos 30. Okay? 24 divided by cos 30 is 16 root 3. So this means this whole length is 16 root 3. Okay? And I'm going to leave it like that on my calculator, might as well. Now, that whole length, I need to take away 6, don't I? So I need to do 16 root 3, take away 6, and then what do I need to add on? Half of the circumference. Okay, so plus half of, what's the circumference? Yeah. 2 times pi times r. Okay? So 16 root 3 minus 6 plus 3 pi. This is going to give me 31.1375 ... 2 significant figures. 31 centimetres.
Is it okay for you to sign it instead of the SOHCAHTOA?
No.
I find it way easy.
Wait 1 second. Okay, so this question done. Perfect. Okay, question 10. The table gives information about the population and the total amount of money in dollars spent on healthcare for 2 countries in 2016. Work out how much more was spent per person on healthcare in Luxembourg than in Austria. Give your answer to the nearest whole number. Right, so really clear here. They've underlined this. Do you think this is important?
Very.
It's per person. So, total population, total spent. Work out how much more was spent per person on healthcare in Luxembourg than in Austria. So, we're going to do the total spent on healthcare divided by the total population, which is something. And then we're going to do the same again for Luxembourg, okay? So we know this is Austria, this is Luxembourg. Okay, so here we go. Let's do it. So there's a trick way to do this. Yeah, if the calculator doesn't work, we're going to do 4.2 divided by 8.7. Okay, 4.2 divided by 8.7 is 0.482, whatever. And then we take away the powers because we have the same base. So this is times 10 to the 4. However, is this in standard form? No. If I multiply this by 10, I get 4.8. Yeah? This is going to be times 10 to the power of 3. Okay? Yeah, we have to move it over. Right, we're going to do the same on the other side. 3.7 divided by 6.3. Okay, because we noticed lately 0.59. We've noticed lately times 10 to the 4, because 9 minus 5, right? We've noticed lately that some of the questions they've given you, did anyone try and put this in your calculator? Did you actually get the answer? You know, sometimes there was like a really big one and then the calculator didn't work. Yeah, that was the last mock, wasn't it? Yeah, I mean, it will come up, so either way. So this is going to be 5.9 times 10 to the power of 3. Perfect, you can check it to the calculators. So, it says, work out how much more was spent. So what we're going to do, one take away the other. However, it wants it to the nearest whole number. So do you know what? I think we should have gone a bit more decimal places. So 4.82758 times 10 to the 3. And then going to have, oh my, I'm going to have to just go back and do this again. I messed it up a little bit. Yeah, I think we rounded too early, everyone. Do not be, you know, it's okay. You might have to go back on it. It's going to be 5.873. 1, 2, 3, 4, 5. 1, 2, 3, 0, 1, 6. Okay, times 10 to the 3. Now we're going to take them away from each other. So this is technically as well 4,827.58. And this is 5,873.02. Okay? Take them away. So 5,873.02 minus 4,827.58 equals 1,045.44. Nearest whole number? 1,045 dollars.
If I'm going to be fully honest,
Perfect. Okay, so I pretty much this is think for the foundation paper. Maybe question 11, maybe not. Okay, so let's go to question 11. Okay, question 11. Now, it's really important. I've seen some people make mistakes on these types of questions. Regardless, okay, you need to use brackets when you substitute. Okay, so this is 6 over, and what's our x coordinate? 0.5. Now in this case they're all positive, so it's okay. I just want to make sure though we get into this habit, because remember our calculator, it takes order of operations seriously. Okay, so we're going to put all this all in here, so we're going to get 12, 3. What's 6 divided by 4? 1.5 and 1.2. Now, believe it or not, you need to use a pencil and you need to be extremely accurate. So, we got 0.5 and 12. Where is 0.5? Well, if this is 1, 0.5 is here, and 12 is up here.
I think we might get a question like this in the next exam.
Okay? So this is definitely going to come up in the next exam, isn't it? And then 1, 6. 2, 3. 4, 1.5. So this is 1. 1.5 is here in the middle. 5, 1.2. 6, 1. Okay, so you can see there, it's actually, this is beautiful right now. Now, when you're drawing this, do not use a ruler. This is a curve. Try and hit through all the points in one. It's a lot harder doing this. Oops. Okay, that's terrible. Start again. So try and get through all the points. Wow, it's really difficult doing this on an iPad. Ah. Okay, one of my students has done this beautifully, so I'll take a photo of this. So here we have a perfect one modelled here by one of my favourite students. Question 12, the diagram shows two vertical phone masts AB and CD on horizontal ground. AB is 6.2, AC is 244, CD is 30.7. Work out the size of the angle of depression of B from D. So what this means is the angle of depression. What does that actually mean? So first of all, you need to get a ruler, right? It's from D to B. Okay? So if you think about it, this is a trapezium, but technically we can draw a right angle triangle here. Okay, so we want the angle of depression from D to B. Okay? So with this one, it doesn't matter which angle you work out first, as long as we know what angle we need. Okay? However, if we're going from D, which angle do you think is the best one to probably work out?
It's the one there. Where from D. For me, when I say angle of depression.
Let's work out this angle here using trigonometry. Oops. Oh my. Okay. So first things first. This is 244. What's our height?
30.7 minus 6.2.
Yeah, 30.7 minus 6.2. Now, can I just say something? It says diagram not drawn accurately. I mean, look how big 6.2 is here and how big 30.7 is, yeah? Of course, it's, we have to, when they say not drawn accurately, they mean it. Okay, so we get 24.5. Okay, so we have opposite, adjacent, hypotenuse. So this is tan of the angle equals opposite over adjacent. SOHCAHTOA. Right? So shift tan. We're going to do tan inverse 244 over 24.5. 244 over 24.5. This is going to give us our angle X equals 84.266, etc. Now, what does it want? One decimal place, which is 84.3 degrees. Okay, but where is this angle of depression? The angle of depression is this one here. So we could have used SOHCAHTOA the other way to find that one straight away. Or what can we do now? 180 minus 90 minus 84.3, which is going to give us 5.7 degrees, okay? Now, this is to show you that whichever way you did this is okay. Okay, if you don't know what the angle of depression is, you still would have got a mark by using 24.5. You still would have got a mark by using tan. Okay? Everyone happy? Okay, question 13. A is root 8 plus 4, B is root 8 minus 4. And it can be written in the form y root 4y. Find the value of y. So first of all, A minus B. Well, what is A? Root 8 plus 4 minus root 8 minus 4, because that's B, right? So I've done this, A minus B. And then we have A root 8 plus 4 plus B. Maybe I'll put these brackets around the A and B. Okay? Now, if you'd have done this, you would have got 1 mark. For those of you looking to get that grade 9, we should be able to spot something. A minus B and A plus B is actually what? The difference of 2 squares. This is actually A squared minus B squared when we expand it. Okay? So even though we've done this, we don't actually have to do this. Okay? But what we will find is this is going to simplify to root 8 plus 4 minus root 8 plus 4. Because minus times root 8 minus times minus 4, right? These are going to cancel. What we're going to get? 8. Multiplied by root 8 plus root 8 is what? 2 root 8. Yeah, because we're adding. 4 minus 4? Nothing. So this is actually going to give me 2 root 8. So we're going to get 8 root 2 root 8. So far, this is 16 root 8. However, it wants it in the form 4y. And why?
Because it can still simplify the 8 root 8.
We can
Root 4 times root 2.
16. Okay. Now, what we have to do is convert this to get the y root 4y. So these two y's have to be the same. Okay? So far we've got 16 and 8. Right? What is the lowest common multiple? 8. Highest common factor. 8. We need to use 8. So 16 is the same as 8 times 2. Something square rooted is 2. What square rooted is 2? 4. This is the same as 8 times root 4 times root 8. Now we've got our 8s here and it wanted 4y, didn't it? So actually, this is the same as 8 times the square root of 4 times 8, which is 8 root 32. So y equals 8. Because then what we've done here is we've manipulated it. The easiest way to do this is to think about, because we could have done this the other way, right? We could have said, well, 16 is the square root of, we could have done 4 times root 8, couldn't we, from 16 root 8? Because that's still true. This is 4 times root 16 times root 8, which is still true. Okay? So we're going to get 4 times the square root of 16 times 8. But can you see what we have on the outside here is not the same as the inside in terms of trying to find this y, and we need one of these to be a 4 multiplied by. Okay, so it is a bit of trial and error, but it's more about sensible guessing. Okay, question 14. A group of 60 students each sat on an algebra test and a geometry test. Each test was marked out of 110. The cumulative frequency graph gives the information about 60 students. Use the graph to find an estimate for the median mark in the algebra test. Okay, what's the median of 60? 30, absolutely. So I've got to go across on 30 and then down. Now, as you can see, I've not even then been as accurate as I could be. You need to make sure you are accurate. This is 42, 4, 6, 8, 48. Okay, make sure you're using your ruler and pencil as we do this together. Next, use the graph to find an estimate of number of students who gained 58 marks or less in the algebra test. Where's 58 marks? It is on the x-axis, it's here, isn't it? So we're going to go up to 58. Oops. Oh no, I've moved it. Yeah, I've gone from the bottom. Up 58. And then across. Probably say this is about 46. Okay, or 45.5. I think if I was to zoom in, it would actually be more 46. Yeah, because it's supposed to cross here actually, isn't it? Okay, just make sure, this is what I mean by the accuracy. Obviously you can't zoom in the exam. Here it's a bit difficult trying to use the ruler and the pen, but that's okay. Okay, 46, brilliant. Nice and easy, 2 marks. So use the graph to find the interquartile range. Okay, what's the interquartile range? Yeah, upper quartile minus the lower quartile. Okay, so the upper quartile, if we have 60 times 3/4, what do we get? 45. So, and my upper quartile is across on 45 and then down. It's roughly here. What is that? 52, 4, 6, 56. So 56 minus, what's our lower quartile? 15. Oh, this is a nice easy one, isn't it? Okay, go across, we're going to get 40. Is everyone doing this at the same time, yeah? Oh my God. Oh, I don't know what happened there. I'm leaving that. This ruler's bewitched today. Okay, minus 40. And what is 56 minus 40? 16. Okay, so interquartile range 16. Says the interquartile range of marks gained in the geometry test is 9. Lewis says the students' marks are more spread out in the algebra test than in the geometry test. Is he correct? Yes? Because 9 is less than 16. Okay?
Miss, when I did it on math, I said because something about the interquartile range was my guy's bigger, so I still work on it.
Okay. Then it says to be awarded a grade A in the algebra test, a student had to gain a mark greater than 64. 2 students are to be selected at random from the 60 students in the group. Use the graph to find an estimate for the probability that both of these students were awarded a grade A at the algebra test. So if the mark has to be greater than 64, first of all, how many students got a mark greater than 64? So let's have a look, shall we? 64 is here. Okay, this is 50. Okay, that doesn't mean 50 students though, does it? What does it mean? 10 students, absolutely. 10 got more then. So 10 out of 60 got more than 64 marks. Now, how am I going to find another student? If I multiply this, how many students do we now have if I already picked one?
59.
It's out of 59. And how many, if I already picked one that already got greater?
So 9.
This is 9. Yeah? Imagine we had 10 students. If I already take one, how many got left? 9. It's out of 59. So I'm literally, in my calculator, going to do 10 over 60 times 9 over 59. It's going to give me 3 over 118. It's nice. I don't think I've ever seen probability like this before. Okay. Make T the the subject of. Step 1, multiply both sides by t cubed. So we're going to get t cubed n squared equals 4d plus t cubed. I want all my t cubes on one side. So I'm going to minus t cubed from both sides. So t cubed n squared minus t cubed equals 4d. Okay? I need to factorise t cubed because I've got two of them. T cubed n minus 1 equals 4d. Divide both sides by n minus 1. T cubed equals 4d over n minus 1. How do I get rid of a cube? Cube root. So the cubed root of 4d divided by n minus 1.
Miss, what if it be n squared inside the bracket?
Oh, sorry guys. Yeah, n squared. Lost the squared on the way. I don't know what happened. Okay? Beautifully done.
What do you minus it by what?
I didn't minus it by 1, I factorised. T cubed times what is n squared? N squared. T cubed by times what is 2 cubed? Yeah. Yeah. So whenever you have 2 and you want to make it the subject, we will have to factorise to then get 1. Because currently we had 2 t cubes here. If we want to try and get t on its own, we just want t. 1t. All right? Question 16. The diagram shows a quadrilateral ABCD. The angle BCD is acute. What does acute mean? It's less than 90 degrees. It's really important we know that fact. Given that the area of the triangle BCD is 405. Okay, is this a right angle triangle?
No.
No. So the formula for this is a half AB sine C. Okay? It's in the front, in the formula sheet. So we're going to do a half times 45 times 36 times sine of the angle X equals 405. Okay? So if I wanted to, I could do 0.5 times 45 times 36. So I'm going to get 810 sine X equals 405. Divide both sides by 810, so we get half. So I get sine of X equals a half. How do I find X? Shift sine. So sine minus 1 of a half is going to give me my angle, which is 30 degrees. Now I'm just checking, is this acute?
Yes.
Okay, that's fine. Brilliant. We got it. It now says work out the size of the angle ABD. So what's this angle here? Okay, so we're going to have to use...
No, he wants angle B.
Oh, sorry, A... Read that wrong, haven't I? ABD. What's this angle here?
This is isosceles triangle, so we can...
How do you know it's isosceles? Because what?
It looks like AD looks equal to BD.
It might look equal, but what does it say?
I'm not sure.
Unless it tells us it's isosceles, or we can clearly, guarantee it's isosceles, you can't just make these assumptions.
But remember there's the question where we had like this
Two regular polygons,
Yeah.
their sides, because they're regular and they both sit on top of each other, they're two sides we know were the same. We know that with full fact. Yeah? We don't know for a fact here. Okay? So we have to use facts only. So first of all, how are we going to find this angle? So
So you just rearrange it, right?
So, we're going to use the cos rule to find this length here. Right? Yeah? So, let's find this length. So, cos rule is in the front. What do we know? it changes. So we know that a squared equals b squared plus c squared minus 2bc cos a. So in this case, our a is our angle, which we worked out, our little a, and this is our b and c. So we're going to have a squared equals 45 squared plus 36 squared minus 2 lots of 45 lots of 36 cos of 30. So 45 squared plus 36 squared minus 2 lots of 45 times 36 times cos 30. I'm going to get a squared equals 515.07, etc. So what does a equal? Square root of the answer. 22.695 ... Okay? So 22.7. However, I'm going to keep that in my calculator. I already square rooted. That's how I got 515 square root. Right, I'm going to keep this in my calculator as answer for the next part. If I now want to find this angle, technically, this is my A, and this is my B, and this is my C. Yeah? I'm going to do the cos rule again, but rearrange it, okay? So, I can rearrange the cos rule to get cos of the angle equals a squared minus b squared minus c squared over 2bc. I've literally rearranged this. I can't remember what they give you in the formula. So in the front of the formula book, you should be able to rearrange this to get this. So we're going to have cos of the angle x equals, now remember, our a squared this time is opposite the angle, okay? So we're going to have 28. So each time you have to really think about what's going on. B, 19 squared minus c, this is my answer, the one we just figured out, yeah, the 22.7 ... squared over 2 times 19 times the 22.7 ... So I'm going to put this into my calculator. So, fraction.
This should be 28 squared.
It should be 28 squared, thank you. 28 squared minus 19 squared minus answer squared over 2 times 19 times answer equals, so I get cos of x equals minus 0.106766. Shift cos answer. X equals 96.1289. 1 decimal place. 96.1 degrees. Did it say anything about it being acute or anything? Nope. There we have it. Okay, made a slight error. This should be minus 2bc, shouldn't it? Yeah, because I divided by it. It's all right, it happens. So, let's start. Let's just put it in again. Please double check your rearranging. It happens to all sorts of people. Right, so, fraction. 28 squared minus 19 squared minus our 22.695, etc. squared over minus 2 times b times 22.695, etc. So you know when I say to you guys, oh, it's just a positive 0.106, oh, of course it is. You know when I say to you guys, always go back and double check. These are the kind of things you should be double checking. 83.87, which is 83.9 degrees. Perfect, well done. These are the things you should be double checking, because these are silly mistakes that can cost you a lot of marks, can't they? Great work. Okay, question 17. Part of the curve of the equation y equals f of x is shown on the grid. Find an estimate for the gradient of the curve at the point where x equals 2. Where does x equal 2? Here. This is where it touches the curve. Okay, if we're just finding an estimate for the gradient, we can go old school. How did we used to find the gradient? We're going to draw a line, tangent to the curve at this point. Okay, here's my line. We need to now find the gradient of this line. So I'm going to pick 2 coordinates that are quite nice. It needs to be tangent. So, for example, you wouldn't draw the line here. Tangent means it just touches. You wouldn't draw the line there. That's ridiculous. Why would you draw it there? Because it's covering over the graph. You're supposed to, for wherever, let's say it was tangent here, you just have to touch it with the ruler, the point, and then you'll be able to draw a straight line.
So because you x equals 2, then you have to draw it where the coordinate meets.
Yes. So here we know that this point is, I think it was 2, 1, right? And then we can just pick another point to help us find the gradient. Which point do we want to pick? 3. We can't pick 3, 3 because it's not quite, but here. So what is this? This is 3. And what do we get here? 3.4. Okay, how do we find the gradient?
y2 minus y1.
Yeah, y2 minus y1 over x2 minus x1. So I'm going to get 2.4 over 1. So what's my gradient? 2.4. I just chose 3 because that's what maths said.
Yeah, but so you can choose
Any point. Remember, you only need 2 points to find the gradient. Or if you didn't want to find the gradient this way, you can literally say this. Well, for every 1 across, okay, from 2 to 3, how far have you gone up? You've gone up 1, 2, 2.4. So my gradient is 2.4. Beautiful. You're going to get it right next time though, aren't you? The line with the equation 2y equals x plus 1 intersects the line 3y squared plus 7y plus 16 equals x squared minus x. Okay? At the points A and B, find the coordinates. Guys, first of all, coordinates look like this, right? And we know it's an x and a y, so we need coordinates. There's more than one, yeah? So, first of all, if they intersect, simultaneous equations. I'm going to rearrange this one. 2y minus 1 equals x. Is everyone happy how I've rearranged this one? Everywhere I see an x in the second equation, what am I going to substitute in? 2y minus 1. So let's do this. So we're going to have 3y squared plus 7y plus 16 equals 2y minus 1 squared minus 2y minus 1. Happy? If you're happy and you know it, clap your hands. Perfect. Right, so I can't really do anything on the left-hand side, but I can simplify this. 2y squared minus 1 is 2y minus 1, 2y minus 1. Yeah? Okay, so what are we going to get? 4y squared minus 2y plus 1. Yeah? Then, these are simultaneous, so that's why I substituted. Minus times 2y, minus 2y, minus times minus 1, plus 1. Okay? So this gives me 4y squared, minus 2y, minus 2y, minus 2y, minus 6y, 1, 1, 2. So I get 3y squared plus 7y plus 16 equals this. Now I'm going to move everything to the right-hand side to get a 0, because then I'm going to have quadratic. I have quadratic, I can see it. So if I minus 3y from both sides, I get y squared. Yeah, if I minus 3y squared, minus 3y squared. Everyone happy? Next, I'm going to minus 7y from both sides. Minus 6y minus 7y? Minus 13y. Brilliant. Minus 16 from both sides? Minus 14, absolutely. This equals 0. Okay, y squared minus 13y minus 14 equals 0. Now, you can either factorise or use the quadratic formula. Do you know two numbers that multiply to give you negative 14 but add to give you minus 13? It's the easiest one. Y minus 14, y plus 1. Okay, if you don't know how to use it, use the quadratic formula or your calculator. So what does y equal? 14, what does y equal? Minus 1. Now we know that what y equals. What did we say earlier? 2y minus 1 equals x. So 2y minus 1 equals x. So we're going to be able to find x for both of these now. So 2 lots of 14 minus 1 equals x. 2 lots of minus 1 equals x. So 2 times 14 is 28 minus 1. 27 equals x. So for this pair of coordinates, I have 27, 14. 2 times minus 1? Minus 2 minus 1? Minus 3 equals x. So then for the second pair of coordinates, minus 3, minus 1. Now, sometimes we do this, and some of you, I don't think, really appreciate what's happening here. Why did we just figure out these coordinates? What are simultaneous equations for? Are you ready? I'm going to blow your mind. You ready for this? Right. 27, 14, minus 3, 1. These are the only pair of numbers for which this is true. Okay? For example, what did we say the coordinates were?
27 and 14 and minus 3 and 1.
Okay. Minus 1. So, for example, 2y equals x plus 1. The only numbers, okay, this is literally saying 2 times a number equals another number plus 1. Try and find 2 numbers for where this works, yeah? The only whole numbers, when I mean whole numbers, I don't mean decimals here, yeah? Just the integers. The only numbers in the whole world that this will ever work for is 27, 14, minus 3 and 1. This is what it's saying. This is saying 2 lots of 14 is 27 plus 1, right? And 2 lots of minus 3 is minus 1 plus 1. Nope. What did I do there? Wrong way around. 2 lots of minus 1 is minus 3 plus 1. So this works for this and works for this equation. Okay, because obviously we'll be able to find other numbers for this to work.
So you have to make sure that these are correct.
But yeah, you can make sure these are correct. But what I'm saying, these are the only pairs of numbers that it will work for this one and this one. I'm saying here that 3 lots of 14 squared plus 7 lots of 14 plus 16 equals 27 squared minus 27. If you put that in, it's going to equal each other. That's the whole point. It's the beauty of mathematics. A, B, C, D is a horizontal rectangular field. A vertical pole, AE, is placed at the corner A of the field. Calculate the size of the angle between EC and the plane ABCD. Right. This is 3D trig. Okay? So, what do we have here? This is 3D trig. Can everyone actually see this is technically a 3D shape? This is a vertical pole and a plane. So technically, we want to find the angle between EC and the plane ABCD. So the angle between EC, oh my, the angle between here and the plane. So that means we have to do a diagonal here. It wants this angle. Okay? So if I was to take this out, I love taking chunks of this out. I like drawing it again. And then I label all the sides properly. This is E, this is A, this is C. Okay? Imagine we've taken a slice of cake. Now, do we know what AE is? 12. Okay, gave us it in the question. Oops. Okay, do we know what AC is? No, we don't. But AC is a rectangle, right? We know this is 18. We know this is 8. So if this is A, D, C, B, are we able to work out AC? Yeah. Our main man, Pythagoras. So, That means AC is the square root of 18 squared plus 8 squared. So, root 18 squared plus 8 squared is 2 root 97. Or, if you press SD, you're going to get 19.697, blah, 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 blah. Okay? You have to be really careful. Please don't use the decimal. Just keep it in third form, and then just put it in brackets when we use it. If we now want to find which angle, this one, what do we have? Opposite, adjacent, hypotenuse. So we have tan. So tan of the angle equals opposite over adjacent. So in my calculator, I'm going to do tan minus 1 of 12 over the answer. Okay, because I can just keep it like that. So shift tan, 12 divided by answer. I get x equals 31.35, which is 31.4 degrees. It's beautiful. Absolutely beautiful. Question 20. Y is inversely proportional to root x. Oh, this is great. I haven't seen one of these in ages. Right, inverse proportion. So y equals k over root x. This is inverse proportion, k over. X is directly proportional. X equals kt cubed. Now, these two k's might be different. Given that when y equals 8, t equals 25. Okay. 8 equals k over root x. Okay. X equals k times 25 cubed. Yeah? All I've done is fill in all the information. However, what do we know about, I think first of all, I'm going to change this k to a different thing. Well, let's just change it to a different colour k.
How do you get x equals cubed?
That's what direct proportional means. So x is directly proportional to t cubed. So that means x equals k t cubed. Okay? So, what do we have? I have two equations here, but these two k's are different. Pink k and blue k are different k's. Different constants of proportionality. Now, what do I have? I have an x here, do I not? Yeah? Okay, but this constant of proportionality could technically be the same thing. Sorry, I've just realised I've put, yeah, t equals 25. Now, do we have an x and an x? So I'm going to substitute this in. Yeah, okay, because when I've got these two, there's nowhere really to go, is there? So 8 equals k over root k times 25 cubed. Okay? Does anyone know what 25 cubed is? And then square rooted.
15625.
Yeah, but we could do it another way. What's 25 square rooted? 5. 5 cubed? 125. Yes, we can do it each way, right? Then you get 8 equals k over square root 125. 125. Could we say it was root k? Kind of. Okay, now this is where we have to think about our k. Our k is just our constant of proportionality, right? So, if I do 8 times 125, what do I get?
1,000.
1,000, okay? Now, with our k's being direct proportion, this is something that technically, because they're both in proportion, we can just cancel them out, essentially. Okay? We can actually just say, well, you know, k over root k is still a constant. okay? Even though this is our blue k here, right? We don't know what this constant is, but we can just say, fine, well, k over root k, our constant, is c. We can call it something different. We can call it a. Now, do we know what k over root blue k is?
K over
Root blue k. No, but we don't care. We just need it to be a constant. Okay, we need it to just be a number that's unknown. So technically, we could just say, well, this is 8 over, give me another random letter. C. Our constant over 125. Hey, it doesn't matter to us what this constant is. We just need to find this constant. So 8 times root 25 is 1,000, not root 25, sorry, 125 is 1,000. So our constant is technically C. So what we're saying now is, find the exact value of t when y is 27. If we want to find t when y is 27, what do we know? We know that y equals our constant over the square root of t cubed. Okay, because we already said that our constant was the k over root k, right? We know that this is actually, so 27 equals 1,000 over the square root of t cubed. So I'm going to get the square root of t cubed equals 1,000 over 27. So technically, I need to square both sides and cube root them. Okay? So t equals 1,000 over 27 squared. That's how I get rid of the square root. Cube rooted. Now the cube root of 1,000 is 10. Cube root of 27 is 3. Square both, we should get 100 over 9. Is that right? You're going to put it in the calculator. You're not going to trust my mental maths, eh? So we should get 100 over 9. Okay? Now, in terms of mathematically, the maths is simple. Understanding that we can manipulate constants this way is a slightly more abstract. All right? Okay, so question 21. Let's have a look at this one. So the diagram shows a solid made from a cylinder and a hemisphere. The cylinder and the hemisphere are both made from the same metal, okay? The plane face of the hemisphere coincides with the upper plane face of the cylinder. The radius of the cylinder and the hemisphere are both x. The height of the cylinder is 3x. The total surface area of this solid is 81 pi. Okay, first of all, I know we should always read the rest of the question. And I've quickly read it in my head, and it wants us to figure out the metal, okay, because it tells us the mass as well. If we have the surface area and mass, okay, and we're trying to find density. Does anyone know what density equals? Yeah, density equals mass over volume, right? So, density equals mass over volume. Okay. Do we have the mass?
Yes.
Yeah. We have the mass. Do we have the volume? No, but we can get it, right? If we've got the surface area, what's the surface area of these two shapes, okay? So in the front of your paper, you have the formula sheet, right? And we have surface area of a sphere, okay? Now, just think about this. Do we have a whole sphere or half sphere? Okay, so when we're doing the surface area of the sphere, so we're going to have the sphere. This is, and it tells you at the front of the formula, 4 pi r squared. Because we have half, what am I going to do? Yeah, divided by 2, right? Plus the surface area of a cylinder, okay? However, the surface area of the cylinder, normally with a cylinder and the surface area, we have the rectangle, don't we? And we have the top and the bottom. But because this top is connected to the sphere, we don't have that anymore, okay? It gives us the curved surface area of a cylinder, which we know. So the curved bit is, you know, that bit that wraps around the middle. 2 pi RH. And then we have to add on the bottom. What is the bottom? Yeah, a circle. So pi r squared. Right, now it's told us the radius is, radius is what? X. So everywhere there's an r, what are you going to write? Brilliant. And then it told us the height is 3x. Oh, I'm going to use a different colour actually, yellow. So everywhere there's a height, what are you going to write?
3x.
And what do we know this all equals?
Equals 81 pi.
81 pi, right? We really couldn't have got simpler than this. So let's do this. So 4 pi over 2 lots of x squared plus 2 pi lots of x lots of 3x plus pi lots of x squared equals 81 pi. Okay? Now, sometimes writing it all out like this really helps us to kind of visualise. It's good to write everything down. And this is how my brain works. Yours might not. And that's okay. We still need to show our method, though. Now, what do we notice about every single term?
There's pi.
There's a pi. So what am I going to do?
Cancel them.
Yeah, I'm just going to get rid of all the pi's because there's one in every single term. I've divided every single thing by pi. It's going to make my life a lot easier. Now I'm going to expand and simplify. So 4 over 2x squared is 2x squared. 2 times x times 3x, 6x squared. X squared, or just x squared,
We can add them all.
equals 81. So I now have 2 plus 6, 8 plus 9x squared equals 81. So what am I going to do? Divide both sides by 9. X squared equals 9. So what does x equal?
3.
Plus or minus 3. However, are we going to have a negative 3 radius?
No.
No. So we were going to reject the negative. We just need to make sure that we understand.
Why do you put plus or minus?
Because if you think about it, minus 3 squared is 9. 3 squared is 9. So technically there's 2 solutions. Yeah? Clever, isn't it? Okay, so what do we know? That x is 3. Okay, so that means the radius is 3. So now I have the radius is 3 and the height, what's 3 times 3?
3 times 3, it's not here.
Yeah, absolutely is 9. Okay, so now what do we need to work out? Volume. Okay, we go back to the sheet at the front. Volume of a sphere, 4 over 3 pi r cubed. But how much of a sphere do we have? Half. So I'm going to divide it by 2. Okay? Plus the volume of the cylinder, pi r squared times h. Now again, now that we know that r is 3 and our height is 9, just substitute in. It's going to be really simple. So I'm going to have 4 over 3 times pi times 3 cubed, all divided by 2, plus pi times 3 squared times 9. I can put that whole thing into my calculator. Okay? I actually get 99 pi. Okay, someone check that, please. So what did we figure out earlier? That density equals mass over volume. So that means density equals mass over volume. Our mass is 840. We've just worked out our volume as 99 pi. So 840 divided by 99 pi is 2.7008, etc. Okay, so which metal is used to make it? Yeah, aluminium. I don't even know if I said that right. Aluminium? Aluminum? We're not in America now. Aluminium. Whoever knows. It's okay, as long as we spell it correctly. Okay, so aluminium. It's like a tongue twister. So you see how that question was didn't really require any hardcore mathematics, did it? It just required you to be able to read the formula, substitute in, rearrange. In terms of the maths, it wasn't actually that difficult. Okay? Okay, question 22. It looks like it's probably going to be one of my favourite questions. Okay? Are we ready? Right. ABC is a triangle in which ABC equals 90 degrees. Okay, so first up, you know what I'm like. How does my brain work? Yeah, I'm drawing a picture. I've got to, right? I've got a triangle, and I know it's a 90-degree triangle. I know a 90-degree triangle is going to look like this. Yeah? Right angle. Perfect. Right. The coordinates at A are P10. Now, this is where sometimes it gets a bit funny in my head, okay? Because now I've drawn a right angle triangle, but it might not make sense with the coordinates we have, okay? So even though I've drawn this, I might change it up now. What I like to do is I like to play imagination, okay? I'm going to go across. This is my coordinate grid, yeah? P. Who knows what P is? I'm just going to bring it here, 10. It's A, okay? B, -1, -5. Right? C, 8. Q. Wait. Oh my God. I'm going here. There we go. This is what I think it could look like. I mean, I'm just making stuff up. However, what I have is a right angle triangle. So can you see actually my triangle's this way round? Yeah? So that's fine. Whichever way you want to draw it, it's completely fine. It's up to you. So I know that this is P10. I know that we have -1, -5, and I know that we have 8Q. The gradient of AC, A, B, C. Okay. Right, the gradient of AC is -6/7. This is -6/7. No, it's not. I'm lying. AC. AC, the gradient of this is -6, -7. How do we find out the gradient? Yeah. Y2 minus Y1 over? Exactly. So, let's have a look at this. If I know it's between A and C, so I have P10 and 8Q. The gradient is Q minus 10 over 8 minus P. What does that equal? -6/7, right? Okay, this is my first piece of clue. Right, this is what I've got. Can I really do anything with this right now? Not really. I mean, I could multiply both sides, do a bit of rearranging. However, I've still got 2 unknowns. Does anyone know anything about straight lines and right angles?
Yes, perpendicular.
Perpendicular. So what does that mean?
Means that they have an intersection and they have a right angle.
Yeah, so it means that BC is perpendicular to BA. Yeah? They have a perpendicular gradient. Or, I mean, there's a few different ways we could do this. The midpoint of AC and B, because this is a right angle, would give us a perpendicular gradient of -6/7. So we could find the midpoint and then do it that way. Which way would you like to do this? What else? Actually, let's keep going. What else do we know about right angle triangles? Forget about coordinates. What do we know about right angle triangles? Angles add up to 180. Brilliant. That's not going to help us here, though. Keep going. What else? Yeah, areas, a half times base times height. Brilliant. What else do we know? What else do we know about right angles? Hypotenuse is the largest side, and what do we know about working that out? Pythagoras. So technically, this squared plus this squared is this squared, right? Yeah? Okay. So, which way would you prefer me to work this out? Okay, so we know that this is the gradient of AC, right? So we'll just put this in a box. So let's work out the gradient of BC. Let's do AB first. So the gradient of AB, so we have P10 -1 -5. Okay. Now, we know then -5 minus 10 over -1 minus P, okay, is the gradient of AB, right? What is the gradient of BC? We have minus 1 minus 5, 8q. So, q minus minus 5 over 8 minus minus 1, right? What do we know about these two gradients? Because they're perpendicular, q minus minus 5 over 8 minus minus 1 has to equal negative 1. Okay? Because we know that one gradient is the reciprocal of the other. So when you multiply the two gradients, they're going to give you minus 1 always. Minus 1 is two gradients that meet at a right angle. Multiplied together, yeah? Two intersecting lines. So let's tidy this up a little bit. Minus 5 minus 10, minus 15, minus 1 minus p. We can't tidy that up. Multiplied by, what's q minus minus 5? Q plus 5, 8 minus minus 1, 9. This equals negative 1. What do we do when we multiply fractions? Yeah, we multiply the numerator and the denominator. So we're going to get minus 15 times q, minus 15 times 5. Over 9 times minus 1, minus 9. 9 times minus p, minus 9p. What does this equal? Negative 1, right? Multiply both sides, minus 15q minus 75 equals 9 plus 9p. Because I multiplied this by negative 1. Brought it up here. Okay, so now what do we notice? We notice something really lovely. We have an equation here, with two unknowns. And we had this equation here, didn't we? Yeah? Simultaneous equations. We just need to rearrange them a little bit. Okay? So, what do we have here? Let's do this.
We can plus 75 with the other side, so plus 75 plus 75. Then we can do minus 9p, so it's going to be, what's it called? Minus 15q minus 9p equal to...
Yeah? There's all sorts of different ways we can do this now. So I'm just going to multiply this out on both sides. Okay? So this one is going to be minus 15q minus 9p equals 84. Okay? Then this one, we're going to get 7q minus 70 equals minus 48 plus 6p. Okay? So you get 7q minus 6p equals 22, I think. Yeah. Okay, so we have two simultaneous equations. However,
Would you have to show your steps for this?
would you have to show your steps for the simultaneous equations? Are you going to put it in your calculator? Well, I mean, you could do if you wanted to. You might have to show it. Well, let's think. What's common between 6 and 9? 54. I'm going to multiply this whole equation by 9. Multiply this whole equation by 6, okay? So, 7 times 9. 63q minus 54p, 22 times 9, equals 198, okay? Then, minus 15 times 6, oh my brain's not working today. Minus 90q minus 54p equals 84 times 6, 504. Okay, now that these are the same, I am just going to use, what do I do?
Just add.
I'm going to add them, aren't I? So, 63 plus minus 90? Minus 27q equals 198 plus 504, 702. Divide both sides by negative 27. Okay, so I get q equals minus 26.
I didn't get that when I put it in.
No, where have I gone wrong?
Miss, I think, so can you go over?
No, I don't want to add them. I want to take them away.
Yeah.
Why would you tell me add them?
Yeah, because then it's going to negative add add them together and remove them. 'Cause
Negative 1, so negative.
Negative 54 plus.
You times it by, when you go back, you times it by minus.
No, I have to minus them.
How?
What do you mean how?
Miss minus 54.
Minus 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 means minus plus. Or else minus 54, right? Minus 54 is minus 108. Right, 63 minus minus 90. Yeah, confusing me all day. 153Q. Minus 54 minus minus 54 is the same as minus 54 plus 54, which is 0. Okay, and 198 minus 504 equals minus 306. So, Q equals minus 306 divided by 153 equals negative 2. Now, if you did just put this into your calculator, I'm not really sure.
Yeah, that's correct.
It says M3 dependent on correct method. So you might not even get this. Okay, now you know what, if Q is minus 2, how are we going to work out P? Yeah, we're going to substitute back in to anyone.
Yeah.
So minus 15 lots of minus 2 minus 9P equals 84. Okay, so we get minus 9P equals 54. P equals negative 6.
Yeah.
Brilliant.
It's all worth 5 minutes.
What? It's 5 marks, was it? Well, I mean, we did have a bit of a conversation about the best way to do it, and if you were doing it on your own, you'd be able to sit this and do this quite quickly. It's about understanding what's happening, isn't it? Great work, guys. Okay, the functions f and g are such that f of x equals x plus 25, g of x equals x squared minus 12x. The function h is such that h of x equals f of g of x. So what does that mean? F of g of x means
You go through.
f of x squared minus 12x. So what does that equal? Everywhere there's an x, I'm going to substitute in x squared minus 12. So I'm actually going to get x squared minus 12x plus 25. This is now h of x. So if I want the inverse of h of x, I want to rearrange this technically to get x equals. How do I do that? Now, whenever we have a quadratic in a function, we have to complete the square, because that's the only way to get x on its own. So we're going to have x minus 6 squared, because that's half of minus 12, yeah? Minus 6 squared plus 25, because we need to see what's left over from the square. So we're going to have x minus 6 squared minus 36 plus 25 is actually minus 9. Okay, so now we have written our function h in a way where we have 1x, so we can rearrange this. So, I don't know how everyone does this, but I like to just put y equals x minus 6 squared minus 9. Okay, we want to rearrange this to get x equals. So, when we rearrange this to get x equals... Wait there, guys. What's minus 36 plus 25?
Minus 11.
Yeah, minus 11. I'm really not with it today, am I? It's too early. Right then, so what's the first thing I'm going to do? Add 11 to both sides. Add 11 to both sides.
Oh,
Okay, what's the next thing?
expand.
We don't want to expand the bracket because then we're going to get an x squared. The whole point of completing the square was that we don't want to expand the bracket. If I expand the bracket, I go back to this. Square root, absolutely. Square root plus or minus square root of y plus 11 equals x minus 6. Now what do I do?
Plus x.
No, plus 6.
I want a plus 6. I want x equals, yeah. So I'm going to get 6 plus or minus the square root of y plus 11 equals x. Okay, now the last bit, because we need to write it in terms of x again, is I just write it instead of y, I put x. So the inverse is 6 plus or minus the square root of x plus 11.
So when you know the square.
You always have to complete the square if you're trying to find the inverse if you have a quadratic. Here we have a quadratic.
Miss, I got confused with something.
Okay? Because x squared minus 12x plus 25, how could you rearrange that to get x equals? Best way to do it is complete the square, because then we're left with an x, okay?
Actually, I got a question.
Go.
So, for the first part, when you got it like as a quadratic, what did you do? Because like, no,
I completed the square here.
no, like this part I understand. But the first part, the top part, how did you get like this quadratic?
F of g of x. Remember I substituted g of x into f.
Oh.
Yeah, okay, did all this. Right, fantastic work, everyone. Good luck with your exams. I hope this helps. We've gone through everything step by step, haven't we? Remember to like and subscribe to Mindful Maths. Have a wonderful day.